we have Christos here, who's going to be talking about secure minimal APIs with .NET 6 and Microsoft Security.
Exactly. Well, what's up, everyone? Thanks for the introduction. I'm here to talk about security. And everybody has been building on they've been building on minimal APIs all day. You've been seeing how .NET has reduced the amount of code that you have to write to achieve things. But my session is all about securing your apps, because we all know that security is important, or I hope you know that security is very, very important. With 2021 projected to cost companies over $7.5 billion worth of damage due to cyber attacks, it comes to no surprise that I am so passionate about security, whichever language. But today we're going to be focusing on .NET. If you haven't seen me before, or if you want to learn more about identity and security in the cloud space or your on-prem apps, then we do have a show, the 4 to 5 show, which actually focuses on showing you end-to-end scenarios. And you can see more about the things that we're going to be talking today in more in-depth stuff. So I invite you there. I don't have any more slides. We're jumping straight into demos, and we're going to be hardcore showing you how to get started with minimal APIs and then build the security on top of that. We're going to build a secure API that requests users to sign in and acquire an access token in order to pass it down to the API. But our API will be doing a few more things. We'll be checking for the right claims or scopes in our application in the tokens, and then it will also use the Azure SDKs to speak to Cosmos. And the nice thing about this demo, as you will see later on, is that nowhere are we going to be using credentials other than signing in with that specific account that we're going to create. But local development, from local development to production, you should never ever have to use any credentials in your code base, in source control, or anywhere that could become an attack vector for your application. And without further ado, let's switch to the command line. I'm using a Mac today, and things are a little bit slow because my Mac has been spinning since this morning. It's probably as excited as I am. Right. I'm going to close down my PowerPoint. I don't need that anymore. Don't save. There you go. So we are, if you have never done .NET Core with identity, we actually have brand new templates that allow you to do this from scratch. So you don't have to actually do a lot of the boilerplate code because it's in there in the .NET command line. So let me just make this slightly bigger so you can see what I'm doing. So if you were to create an application, I'm going to come here because it's cleaner. If we're to say, I want to create a new API that does have some security out of the box, we will do .NET new. I think this needs to be bigger. I can't see it. .NET new web API, or web app if you're creating web apps, and then --auth. That magic flag over there will allow us to add all the templates that we need in the code. And then if you're working with Azure Active Directory or B2C, then this is where you choose your tenant or your identity options. So we'll do single org. And then there's a number of extensions in the command that allow you to do a lot of things from the command line, so you don't really have to jump back and forth. So if you haven't seen it before, -h will allow us to actually look at all these things. We can call other APIs if we wanted to. We can configure certain things like the tenant out of the box. But I'm going to save you the trouble of seeing all that, and I'm going to jump straight into my VS Code. And the VS Code here actually has exactly what would come out of the box if you were to do .NET new web API with authentication. So some of the things that you'll get here is in the app settings. You'll see we have some placeholders for what the Azure Active Directory settings should be. And then in the program, which now is the entry point, there's no startup.cs anymore. We have the on line 8, we have the add authentication for our API. Now this is not configured, so if we were to run this one, it will actually fail and crash. So the next step would be to add the identity on that and configure the settings. So for that, I'm going to be slightly clever, and rather than you see me typing all the code, I'm going to switch to a different branch. So git checkout authentication. I've done all the hard work, so all we have to do now is walk through the code and see what actually happens in our code. I've even simplified stuff a little bit. So back into our program.cs, we have one line of code. That's all you need to configure your authentication out of the box. So if you're not doing anything exotic and you're just getting the default, then that's line 7 for you. And then line 8 says I want every incoming call to be checked that has a token. If an incoming request for our API comes without a token, then the user will get a 401. And if the token comes and doesn't have the right permissions, they will get a 403. How does that work? Well, I do have a couple of placeholders down here. So I built a bare bones API, and I have a Cosmos backend, which will plug in a bit. But right now I have a couple of endpoints. One is a get endpoint, app map get. It's so easy, right? And then we say what the endpoint will be. That's volcanoes. And then if you pass a name, then it will actually look for that specific volcano information and pass it back to the user. If you don't pass a name, then it will just bring you all the volcanoes. And the magic here in this function is in line 18, where I'm saying you need to verify the user that when the incoming access token comes in, that the user has the right scopes. And this allows us to be a little bit more flexible. So for example, you can have multiple scopes. You can have a read-only or read-write scope. So the user will need to consent to those scopes and get the token. If they can't get those claims, then they won't be able to access it. So if line 18 hits in the incoming call, then if the user doesn't have the right claim, then they will get a 403 back. So that means that not only does our middleware checks for a valid token, it hasn't expired, it came from the right tenant, it also is for the right audience, i.e. our API, but it also checks that for inside that specific API endpoint, we have the right claims to call that. And then there's a post that actually uploads a new volcano data to our backend. And again, here we also have a check on line 30 to do the exact same thing, to verify that the user has the right scopes. And with the new .NET 6, that declaration of the fact that we need to have an authenticated call is through the require authorization line down 27. So you see that both methods have that. That's all it takes. Now, at this point, again, we're not ready to run our application because if I remember correctly, I don't think I have the settings. Well, I do have some settings, but they're junk. I want to recreate them. And in the old days, or if you like to use UIs, then you would jump onto the portal, right? You would jump onto the portal, let's say again. The Azure Active Directory, that's the portal that most of the developers will be interacting with if they need to, but I don't want to use this because it doesn't scale well. Anybody in my team will have to do the same thing if they wanted to use their own application. So what I did this time is I went and created a .interactive notebook. And what this notebook allows me to do is to actually configure my Azure Active Directory programmatically from inside my VS Code. Now that can also be checked into your source control, and because this code is .NET, you can also execute it anywhere you want. So let's go and actually do that. So first, I'm going to download some NuGet packages. And the nice thing about this is that the latest libraries, the Microsoft Graph, that allows us to interact with most of the Microsoft APIs, has been updated now to use the Azure SDK's identity library out of the box, which makes authentication much, much simpler. So with these libraries in place, we're going to create an interactive browser credential, which will pass later on to our code to go and configure. It gives us actually the authentication context to interact with Azure Active Directory. Now, this is where the magic happens. On this part of the notebook, we're going to create a new API called .NET Conf Demo API, and we're going to add some scopes. And then in there, we're going to do some configuration. We're going to dump some information that we're going to need to configure our app. So let's run this one. It actually prompts me for authentication. So I'm already signed in. It says you authenticated. So if all goes well, at the very end, we should see all the information we need. So that's perfect. Now let's grab that. And let's go to our app settings and configure that. Configure what we need. So in our code under app settings, we need to add the client ID. Everything else is the same because I am reusing the same tenant. So technically, that's all we need to change. But if I wanted to grab that information, it's actually dumped here. Domain, tenant ID, and client ID. Everything I need to configure my API. So that is my API component. It's all done. Actually, it's not all done. We need a service principal so we can consent to that information. We did it. The next one is, since it's an API, it's not really, there's no user interactivity there unless I have a client. You can use Postman, you can use REST API tools, but I have an extension under my VS Code, which I take with me everywhere I go. It's called Thunder Client, and it's a perfect tool because it allows me to run calls to my APIs directly through here. And for that to work, I actually need some configuration settings. Again, you'll see I have some placeholders here, but there's an authentication authorization tab, and under here I don't have any information. So if I were to do any calls right now, it will come with this dreaded 401 unauthorized. So to configure this, it's slightly too big now, and you can't probably see everything, but let's take it here. So we need the auth URI, the token URI, and a client secret. This is the only secret that you will see in my demos today. It will be deleted after my demo, but this is what you need to do if you have a client. And because it's a specific client that does the requirement to go and call your Azure Active Directory and get the token, we need to have a secret because it uses the client secret flow, right? So with that, we're gonna go back to our notebook and then run the registration for the client app. And lo and behold, this is what we need. So let's go grab the client ID. I'll come back to so that's the client ID here. We need a secret. I'll get back to that in a second. We also have the authorization endpoint. This is where we're going to authenticate and grab the access tokens in a second. We also need to run the app at some point. And here, the token. It's mainly me copy pasting things. And the client secret. Again, there's an API call to allow you to create a secret for your app registration. So here in a couple of seconds, we'll take that. Do not dox me live on .NET Conf. And we need a scope. Now that scope is the specific scope that our application is expecting. Remember, if we go back to our code in our program.cs, remember that access as user, we need to have that. But to request this, we need the resource URI, which I actually dumped cleverly further up. Let's say cleverly. Okay. So the app URI is here. Convenience over security, I guess. So over here, we'll add the scope. And state is optional. You can just add something. It's just nonce for the call. With that, I can go to my generate token, and this will ask me to authenticate. I need to authenticate with the same account or an account that is on that tenant. I'm getting asked to consent to that app because it's the first time I'm using it, and I need to get the right permissions. And if that works as expected, we should see the success, and eventually our access token will be populated up here. Now, the application is not running yet, so let's go and run the app. .NET run. Just thinking about it. Okay, so our endpoint is here, HTTPS localhost 7175. Surprisingly enough, .NET 6 has made the port random. So just be aware the next time that you run .NET 6 and you configure things. For identity perspective, it was always localhost 5001 for Kestrel, and then now we need to make sure that we check the port before we do anything, or you can hard code the port. That's totally up to you. Now the API is running, and I have everything I need. I have the token, so if I do call, it's unauthorized. Let's see why it's unauthorized. So it's a live demo. So we need to make sure that we have the client ID. I'm calling. So it's usually the resource. So just need to make sure that we have the right resource. And back into our config. See, always gets me, VS Code. I haven't saved my JSON file. And therefore, remember when we changed the client ID, which was the only thing I changed? I forgot to save it. So let's save and rerun. I was just making sure that you've been following along, right? Okay, so now if we call our endpoint, you're getting all the volcanoes. Obviously, we're not getting any data, but we did get, we're not getting any data from Cosmos, but we are getting a response back from our API, which means that all our security components have passed. This is good. The next step for us would be to call resources. Usually APIs and web apps tend to interact with data. And when you interact with your data, you need to do it securely. Remember, security in layers. So the first barrier to security, or the first barrier to access, or unauthorized access, was to ensure that our API required an authenticated token to be passed. But however, at this point now, I can call my backend, and it can be under any context. It can be under the user's context, so we can do on behalf of the user, or we could actually use credentials from within the application to call our backend. Back in the good old days, you would call SQL, you would pass a connection string into your web config or whatever config you were using, and usually in there was a string that contained a secret or a password, unless you were one of my customers in the past where the credentials were SA and no password, because who would think about cracking an account that doesn't have a password, right? Please don't do that. That was dev and production, by the way, so please don't. Anyway, let's hope that you're using passwords, but passwords are so last decade. With Azure, you get the ability to connect to many, many Azure resources using a managed identity. That managed identity, in effect, tells the application that there is a context between the front end and the back end. It's a shared context, a security context, and allows us to communicate between services without passing credentials. All that is backed by Azure AD, so you as a developer, you as a user, don't have to worry about storing secrets or passing them around or putting them in environmental variables or doing anything that could actually allow attackers to mount an attack. However, in a local environment, we don't really have managed identities because we are not running on Azure. There are ways around it. For example, I could Azure Arc join my machine onto Azure, and that would allow me to, in effect, get a managed identity. And the Azure SDKs work with Azure Arc to allow you to pick up the local credentials for the managed identity. This machine is not Azure Arc joined. And also with Azure Arc, there are some limitations. So instead of doing that, I'm going to use a service principal. This is the next best thing, although it's not ideal because I still have to pass some credentials somewhere, which we'll see in a second. However, the idea here is that that service principal will have very limited resource access on Azure. One of the mistakes that developers tend to do is that instead of using a service principal on their local environment, they will use their local account or my account. For example, if I switch to this page here and then say clear, and then I issue the AZ account show command because I signed in earlier on, you will see that I'm running as my domain account on my Azure subscription. This is extremely dangerous because I am an owner of that subscription. I can do insane amount of damage. I can delete databases if I run the wrong script. And I can, in effect, if somebody takes hold of my terminal, they can have a lot of access in there. So instead of doing that, we can actually create a service principal account, and you will see here through the script how to do that. So let's stop the application from running. Let's switch to my other repo. Cosmos. That's the name of my other repo. I did some changes, and then I need to abort them. So I'm going to cancel this one, don't save, git checkout, and then okay, so now we're in the Cosmos branch. Let's clear this, and I'm going to take you back to the code so we can see what's changed, and then run the command. So very, very quickly, in our code here, there's more code. Let's hide our files, and then let's see what the code is doing here. A few more things have been added, a couple of more libraries. I need to do a .NET restore, and then we have a token credential. This is the key here, and there are different versions of token credentials, but I always like to be very explicit with how my credentials are generated. There's a default Azure credential that brings everything. It brings Visual Studio Code. It will look for environmental variables. It will look for PowerShell options. It will look for interactive if you decide to do so. So everything can be used there, but it's everything. And I don't like getting credentials from different places. I don't know where they come from. Therefore, I tend to usually go with the Azure CLI credential on my local environment and then the MAS identity credential when I'm running in production. The nice thing about this code is that you don't have to change anything. It just runs out of the box. And then we have our Cosmos endpoint, we have a Cosmos client, and then we populated the endpoints now to actually return some code, return some data. And without that, I'm going to build and run. Just thinking about it. And while this one is happening, I am going to, okay, a few restores, done. And I'm going to switch back to my VS Code. I'm going to open my Cosmos script. And in here, we're going to do a few things. I'm already logged in. I'm going to create my service principal with a very limited scope that can only access that has reader access to my Cosmos. So this one's running. I'm going to go back very quickly. I'm going to grab the object ID because we need that. It doesn't work with the app ID out of the box, so we need this. Before I do that, I need to copy that information because we'll need to sign in as the user. And then in our, we're going to grab the object ID. We need that as well. I don't want to press the wrong things. Okay. So here we need to change that to be the one we just copied without the extra quote. And then what I'm doing here is I'm actually assigning my service principal read-only permissions to my haven't done that yet. That's the population, and then role assignment here. This one is actually assigning that service principal read-only permissions, and that's a custom permission I created, but we have updated the RBAC permissions for Cosmos, and there's a read-only permission out of the box and a read-write permission out of the box. So you don't have to create custom ones unless you want to be very explicit about how it's used. That's all done now for us. And then I know that we are going to sign in with that user over here. That's the last step. But I also have one step which I forgot. No, obviously, that user doesn't exist. Remember, that's why we copied it. So here, placeholders, secrets, and app ID. And run that. So it's signing in with that user. And while this one is happening, I just remember that my app settings have not been updated because I need to use a different app ID. And that app ID is in my previous version. So let's switch to authentication. Cosmos. Let's change that. few more seconds. Just to prove that it works, right? And there. And now I can run the app. It's running under the context of that service principal. And if I go back to my VS Code, if I request my volcanoes now, I think I have something wrong here. I think it's the authentication settings, and I bet you it is the wrong app ID. Almost there. Last time. And sending it. Cool, we got it. Now if I were to run the post, it would fail because this account does not have write permissions. This code is all on GitHub, so if you want to see how it works and run it on your own environment, be my guest. Just a very quick recap. Security is very important. We all have a responsibility to create secure code. Microsoft Identity makes it a lot easier to do this, and .NET has made it significantly simpler by just adding a couple of lines of code. As you saw, most of the identity was very, very simple to implement. I spent most of the time configuring the backend and the permissions. Thanks for watching, and I hope you learned something today. Thank you.
Thank you, Christos. That was excellent. I'm glad to see those demos pull through. Just a little moments of waiting, but that's kind of how deving works these days.
Indeed.
We do have time for a couple quick questions. You ready for them?
Let's go.
All right, cool. So, where can I find an example of authorization without Azure?
Without Azure? Well, there are a lot of identity providers out there. If you don't use Azure, I assume it's Microsoft Identity, not Azure, but if you're not using Azure Active Directory or Azure Active Directory B2C, there are other identity providers, and I would urge you to use something other than rolling out your own. So that's a great question. Please don't roll your own authentication. There are plenty of examples out there, blog posts and videos on YouTube. So just search for authentication with .NET and you'll find stuff.
You'll find all you need to know. Okay. Cool. So, is there an easy possibility to have a JWT only within the browser, like HTTP only secure, for high security requirements, and how to configure the cookie for that? And greetings from Munich.
Well, hi Munich. Thank you for the question. So JWT, if you don't use an identity provider to issue a JWT, then you can create your own API that issues its own JWTs. The challenge there is to validate and ensure that the consumer of that JWT is actually the intended one, right? So nobody steals your JWT in transit or whatever. With regards to persistence, you can decide how you want to persist, whether it's a cookie or some other browser storage, but again, it's all configurable and doable, yeah.
Great,
thank you.
Great to know. Christos, thank you so much. That was amazing.
Thank you for having me.